Dear students, today we are going to discuss another inventory model. That model name is inventory model with the planned shortages. So far, we have studied economic order quantity and economic lot size quantity. There we did not consider the concept of shortages. So, in this lecture we are going to consider the concept of shortages, then we are going to develop a new model for considering this shortage cost. So, the agenda for this lecture is inventory model with planned shortages. You remember, the shortage is planned. In advance we are planning for shortages because we are going to say that there is an advantage of this shortages. So, that is the agenda for this lecture. So, inventory model with the planned shortages. A shortage or stock out occurs when the demand exceeds the amount of inventory on hand. Whenever the shortages occurs, when it happens that whenever the demand is more than the inventory on hand. In many situations, shortages are undesirable and should be avoided if at all possible. In practice, these type of situations are most commonly found where the value of the inventory per unit is high and hence the holding cost is high. Look at the example, look at the picture which is in the right hand side, it is a car dealer. Most of the time if you want to buy a particular car, they will ask you to wait for some days, because if they keep that car in inventory, the inventory holding cost is high. Okay. So, in this kind of business scenario, this kind of inventory model with the planned shortage is more suitable, where when the inventory holding cost is high. Before going to this topic, first we will understand the concept of back order. What is the back order? This model developed in this lecture takes into account the type of shortage known as back order. So, what is a back order? Back order is defined as an order received for goods or services, but cannot be fulfilled and can be due to various reasons such as non-availability of the ordered product, or the stock being still in the production phase, or the order is placed with manufacturer and delivery is still pending. So, this is the definition of back order. Look at this picture on the right hand side. There is a person A and dealer. Okay. So, the person A want to buy say 10 buses, but the dealer has only 4 buses in inventory. He cannot deliver all the 10 buses at a time. So, what he can do? He can take 4 from the dealer and ask the dealer to deliver remaining buses within 2 months. The person A has to wait for 7 to 8 months for remaining buses to receive. This is the concept of back ordering. For example, say this is the 7th month, say this is 8th month, say month. Okay. So, he has ordered something, but this order is not fulfilled. So, what we will do in the next month, right, we will first to fulfill the previous month order. Okay. That is the meaning of this back order. The 7th month we are not able to fulfill the order. For example, the same problem, say here say 10 buses is required, but we are able to fulfill only 4 buses. So, remaining 6 is the shortage. So, the remaining 6 we will be manufacturing on the 8th month, then we will settle, we will supply that remaining 6 buses to the previous month. So, this is the meaning of this back ordering. So, we are going to consider this concept of back ordering whenever there is a shortage occurs. Inventory model with the planned shortages. Let S indicate the number of back orders that have accumulated by the time a new shipment of size Q is received. Here S is the number of back orders, shortages. Then the inventory system for the back order case has the following characteristics. If S back order exists when a new shipment of size Q arrives, then S back orders are shipped to the appropriate customers. So, what is happening? Suppose we are receiving Q quantity, already there are S shortages. So, as soon as we receive the order, so this S quantity will be shipped to the appropriate customer, that means person who is already waiting. So, the remaining Q minus S, this Q minus S units are placed in inventory. Therefore, the Q minus S is the maximum inventory. Look at this picture on the right hand side. In the y axis is the inventory. So, the Q minus S is the maximum inventory. The negative S represents the shortages. There is a T1 and T2. This model is similar to our economic order quantity. How it is similar? That whenever we place the order, the replenishment taking place immediately. Okay. So, during the small T1, okay, during this period there is a shortages. So, total cycle time is combination of T1 plus T2. T2 is where there is no shortages, T2 is where there is a shortages. So, the Q minus S is the maximum inventory. The inventory cycle of T days is divided into two distinct phases. T1 days when inventory is on hand and orders are filled as they occur. T2 days when the stock out occurs and all new orders are placed on back order, because due to shortages this will be kept for the back order. Unless our previous two techniques, what are the cost we have considered previously? We have considered holding cost and ordering cost. So, in this model, apart from these two costs, we are going to consider another cost, that is called back order cost. What is the back order cost? Labor and special delivery cost directly associated with the handling of the back order is called back order cost. So, the back order cost, it is denoted as CB, is one of the most difficult cost to estimate in inventory models. The reason is that it attempts to measure the cost associated with the loss of goodwill, is the perception only goodwill when a customer must wait for an order, because we cannot quantify the loss of goodwill. That is why we say that the measuring the back order cost is very difficult. So, expressing this cost on an annual basis adds to the difficulty. Because of this, loss of goodwill cannot be measured. Component of back order cost, that is the goodwill cost. Another portion of the back order cost account for the loss of goodwill, because some customers will have to wait for their orders. Because the goodwill cost depends on how long a customer has to wait, it is customary to adopt the convention of expressing back order cost in terms of the cost of having a unit on back order for a stated period of time. So, what is the meaning of this cost? Suppose say 7th month, okay, and this is 8th month. So, 7th month there is a shortage, say the shortage is say 10 units. Okay. So, what will happen in case if you are holding this 10 units for this one period up to 8 month. So, that inventory holding cost can be considered as the your back order cost. Okay. This method of costing back order on time basis is similar to the method used to compute inventory holding cost. It is similar to inventory holding cost, and we can use it to compute a total annual cost of back orders once the average back order level and the back order cost per unit per period is known. So, later we will derive this, we will derive this average back order level, then we will multiply that one by the annual back order cost. So, that we will get the annual back order cost. As usual, we will go for calculation of average inventory. If you have an average inventory of 2 units for 3 days, you are having 2 units for 3 days and no inventory on the 4th day. What is the average inventory over the 4-day period? So, 2 units you are holding it for 3 days and 0 units, this is a shortage for 1 day. What is the total duration? 3 plus 1, 4. So, when you simplify it is 6 upon 4, it is 1.5 units. So, this is a sample calculation for finding the average inventory. So, this idea here, see that there is a shortage This idea we are going to use to find the average inventory whenever there is a shortage. Average inventory with a maximum inventory of Q minus S units, we know that the maximum inventory is Q minus S, and T1 days, see this is also Q minus S. The T1 days we have inventory on hand. Okay. So, up to this T1 days we will have inventory on hand. So, the average inventory is Q minus S upon 2. This is the same idea we have used when we are deriving the economic order quantity also EOQ. So, there we used Q by S, maximum inventory divided by 2, but here also instead of that we are using Q minus S upon 2. So, no inventory is carried for the T2 days. During this period there is no inventory, in which we experience the back orders. Thus, over the total cycle time, that is T1 plus T2 days, we can compute the average inventory as follows. In the previous slides I have explained how to find out the average inventory. So, what is that? This much amount of inventory 1 upon 2 Q minus S T1 plus T2 period there is no inventory. So, it is 0 divided by T1 plus T2. So, when we simplify this 1 upon 2 Q minus S T1 plus capital T, this is the average inventory. In that previous expression we are going to replace this small T1 and T in terms of Q, that is what we are going to do. So, the maximum inventory Q minus is, and the D represents the constant daily demand. So, what will happen when you multiply, see, to get Q minus S, what we have to do? The per day demand multiplied by the T1. So, that will give you the maximum inventory. From this Q minus S equal to D multiplied by T, we can get T1, we can get T1 is Q minus S upon D. So, the T1 we can express in terms of Q minus S upon D. What is the small d? This is constant demand rate, that is the maximum inventory Q minus S units will be used up to Q minus S upon D days, that is your T1 days. The another expression we are going to find out for capital T, we know that the Q units are ordered for each cycle. We know that the length of the cycle must be, see what is the Q? Q equal to T length of the cycle and per day demand. So, from this expression we can find out the Q, T. What is the T? It is a Q upon small d. So, we got a expression for T1, small t1 and capital T. So, these expressions we are going to substitute in our average inventory formula. So, by putting value of T1 equal to Q minus S upon D and capital T cycle time equal to Q upon D in the equation of average inventory. So, we are getting 1 upon 2 Q minus, instead of T1 we are going to substitute this term Q minus S by D, instead of capital T we are going to substitute this Q by D. D is per day demand, Q is quantity ordered, S is the shortage. So, when you simplify this D get cancelled. So, the remaining is 1 by 2 Q minus S whole square divided by Q. So, look at this, the average inventory is expressed in terms of two inventory decisions. One is how much we will order Q and the maximum number of back orders that are permitted. Okay. That is what in the end we are going to find out this, what will be the optimum order quantity and what should be the optimum shortages allowed. So, this is average inventory, expression for average inventory. So, from this we know as usual the annual number of order is D upon Q. D is the annual demand, Q is the quantity ordered, that is the number of orders. Now, we will derive the expression for the average back order level. We have an average number of back orders during the period T2. that is half of the maximum number of back orders. Look at this here. So, this distance when you put this A, see this distance is the average number of, this is S minus S, average number of back orders. This is S, when you divide by 2 you will get the average number of back orders. So, we do not have any back orders during T1. Therefore, we can calculate the average inventory. So, 0 multiplied by T1, because during T1 there is no shortages, plus what is the unit here, S upon 2 during T2 times. So, when you simplify this, S upon 2 T2 divided by capital T. Here also we are going to find the expression for T2 and T in terms of Q, that we are going to substitute here. So, what is T2? When we let the maximum number of back orders reach an amount S at a daily rate of D. So, D is daily rate of your shortages. So, what will happen? Yes, the total shortages, total number of back orders in terms of unit is daily rate multiplied by T2. So, from this expression we can get T2 is S upon D. Q units are ordered for each cycle, we know the length of the cycle must be T equal to Q upon D. So, we got the expression for this T2 and this already we have expression for T. So, these two expressions we are going to substitute in our previous equations. When you substitute there, what will happen? The average back order is S upon 2, instead of T2 we can substitute S by D, instead of capital T we can substitute Q by D. So, when you simplify, D get cancelled. So, remaining is S square by 2Q. This is average back order. Previously we have seen the average inventory, now we have got the expression for average back order. Now, as usual we find out the total annual cost for inventory model with the back orders. What are the expression for different cost? CH represents cost of holding one unit in inventory for 1 year as usual. CO is the cost per order. The new term is introduced here is a CB, cost of maintain one unit on back order for 1 year, that is a back order cost, we can call it as a shortage cost. So, the total annual cost TC for the inventory model with the back order becomes, see this is the average value of Q, this is average value of shortages. So, when you multiply by CH you will get the holding cost, ordering cost plus back order cost. In the EOQ definition we had only these two, holding and ordering cost. Now, in the shortage inventory model with the shortages we are having one more component, that is the annual back order cost. So, this is the equation. This we are going to, here we have to find out the optimal value of Q, call it as Q star, and the optimal value of S. What is the Q ordering quantity? What is the S star? Is the allowable shortages. So, there are two variables here. So, I am going to differentiate this equation partially with respect to Q and S and going to equate it to 0, then I will get the expression for my Q star and S star. So, this expression, if y equal to u upon v, the formula for differentiation is dy by dx equal to, in the denominator there will be v square, in the numerator v du by dx minus u dv by dx. So, in this expression I am saying about in this expression what is the value of u, what is the value of v. So, here the value of u is q minus s whole square, the value of v is q. Okay. So, when you substitute, when you use this formula for differentiating, so CH by 2 is the constant I have taken to the left hand side, then V square Q square, then V du Q, okay, du is Q minus S whole square. When I differentiate 2 Q minus S, again Q, it will become 1 minus U. What is the U here? U is Q minus S whole square. What is the dV by dx? That is the 1. So, Q minus S whole square. This plus here plus d by q, when you, if it is 1 by q, when you differentiate, it will be minus 1 by q square d c naught. This also S square 1 minus 1 by q square C b equal to 0. Now, the same expression, this expression I will differentiate with respect to, partially differentiate with respect to S. So, when I differentiate this one, 2 q minus S minus 1 by 2 q C h. So, there is no term here, this will be 0 plus 2 S C b divided by 2 q equal to 0. When we further simplify, so q minus, I am saying this one, q minus n minus 1 C h plus S and C b equal to 0. When you further simplify, minus q minus S C h plus S C b equal to 0 minus q C h plus S C h plus S C b. So, minus q C h I am bringing it to the right hand side. So, S C h plus S C b equal to q C h. So, S is the constant. So, C h plus C b equal to q C h. So, S is q multiplied by C h divided by C h plus C b. What is the S? Allowable shortages. Q is the optimum ordering quantity, C h holding cost, C b is the back order cost. So, dou T divided by dou Q equal to 0. So, we got this expression. What is this expression? Is our dou T by dq. So, this expression I am going to multiply 2 by 2 q square on both sides. So, when I multiply by both sides, what will happen? 2 q square and 2 q square will be there, only C h 2 q and q minus s will be there, minus q minus s whole square minus 2 d c naught minus s square C b equal to 0, this expression. If you further simplify, C h 2 q square minus 2 q s q minus s whole square, like a minus b whole square, then you bring minus inside. So, q minus q square minus s square plus t q s, then minus 2 d c naught minus s square C b equal to 0. So, minus t q s and plus t q s will get cancelled. So, C h is the common. So, when you take C h on left hand side, it will become q square minus s square, because 2 squares minus 2 q square minus q square, there will be 1 q square minus s square, then minus 2 d c naught minus s square C b equal to 0. So, bring this C h inside, it will become q square C h minus s square C h minus 2 d c naught minus s square C b equal to 0. I am grouping. So, q square C h minus 2 d c naught minus s square, because s square is a common. So, minus s square C h plus C b equal to 0. Okay. Already we know the expression for S. Okay. When you substitute the, what is the expression for S? S star equal to q C h divided by C h divided by C h plus C b. When you substitute this S star value in our equation, instead of S square we are going to substitute this, the value of this S square. So, it will become q square C h divided by C h plus C b whole square. So, this expression. So, S square we are replacing by this one. Then CH plus CB is there equal to 0. Now, further when you simplify, so you are getting Q square CH minus 2D C naught minus Q square. See that CH square divided by CH plus CB, previously there was one square was there, that was removed. So, now when you multiply by CH plus CB on both sides, when you simplify you will get minus 2D C naught plus Q square CH, we are multiply by CH plus CB, CH plus CB minus Q square and CH square divided by CH plus CB equal to 0. So, when you simplify this Q square CH square and Q square minus Q square CH square, we can cancel it. So, the remaining is minus 2D C naught plus Q square CB CH upon CH plus CB equal to 0. When you multiply by CH plus CB on both sides, so you are getting this expression minus 2D C naught CH plus CB plus Q square CB CH equal to 0. So, when you bring on the right hand side, so where we get the value of Q square. So, from Q square when you take the square root, you will get 2D C naught CH plus CB divided by CB CH. So, here slightly I am going to readjust this. We know that this expression 2D C naught CH. So, you see that, remember this expression is our formula for our traditional EOQ, sorry EOQ. So, I am grouping 2D C naught CH. So, this term CH plus CB by CB is the new term we have added into this model to find the value of Q star. Given CH holding cost, ordering cost and backorder cost and annual demand D, the minimum cost values for the order quantity Q star is this expression root of TD C naught by CH multiplied by CH plus CB by CB, and the planned backorder S star is Q star multiplied by CH divided by CH plus CB. Now, we will take one problem, then we will apply these planned inventory shortage model. An example, a company has a product for which the assumption for the inventory model with back orders are valid. Information obtained by the company is as follows: annual demand is given, interest rate is 20%, unit cost is $50 per unit. So, from this expression we can find out the unit holding cost per year. So, 0.20 multiplied by 50, you will get $10 per unit per year. Ordering cost is $25 per order. The annual back order cost is estimated to be $30 per unit per year. So, the value of CB equal to $30. We know already the expression for Q star. So, when you substitute this, we are getting the optimal order quantity is 115. Next, we will find out optimal shortages permitted. We know the formula for shortages is this Q S star equal to Q CH okay. So, S star is Q CH holding cost divided by holding cost plus shortage cost. So, from the previous expression we got the value of Q, that is 115. All other values are simply substituted, we are getting the value is 29. That is, what is the meaning of this 29? Permissible shortages. If this solution is implemented, the system will operate with the following properties. So, the maximum inventory, what is the maximum inventory? So, the maximum inventory is Q minus S. What is the Q minus S? 115 minus 29 is 86. What is the cycle time? Cycle time is, for example, some period there will be the shortages. So, what is the cycle time? Q upon D. Assume that the company works for 250 days per year. So, 250 divided by number of order is, so when you simplify it will be Q by D to multiplied by 250. So, 14 working days, cycle time is 14 working days. So, what we can do from this expression, we can find the annual holding cost. Annual holding cost is, we got the expression for the total cost. What are the elements of total cost? Holding cost, ordering cost and back order cost. Individually we will find out what is the total cost. Holding cost is Q minus S, just now we got this 86 divided by 2Q. What is the Q? 1115 multiplied by holding cost is $10, so 322. Ordering cost, D by Q, D is 2000, Q is the quantity 115, so ordering cost is 25, 435. The back order cost S square divided by 2Q, S is, S star is 29, 29 whole square divided by 2, Q is 115 multiplied by 30, 30 is the back order cost, we are getting 110. So, when you add these three costs, we are getting 867, that is the annual inventory cost when there is a shortage. Instead of solving the same problem, if you consider without shortages, if the company chooses to prohibit back orders, not allowing shortages, and adopt your regular EOQ model, the recommended inventory decision is, we know that the formula 2D C naught divided by CH, that is your Q star. Okay. 2, demand is 2000, order cost is $25, holding cost is $10. So, we got the Q star is 100 units. For the 100 units, we can find out the holding cost. What is the holding cost? Average inventory Q by 2 multiplied by per unit holding cost. So, annual holding cost is 500. Annual ordering cost, number of order multiplied by ordering cost. So, number of order is 2000 upon 100 multiplied by 25, that is 5000. So, the total cost is 1000. Now, you see in this problem, allowing back order is projecting how much? $100 minus 867, 133 or 13.3 percentage saving in cost from no stock out EOQ model. So, what the comparison we are doing? If you go for with shortages and without shortages. So, without shortages, our cost is $1000. With the shortages, total annual inventory cost is 867. So, $133 is the saving due to this planned shortages. Concluding remarks: if back orders can be tolerated, the total cost including back order cost will be less than the total cost of EOQ model. That means that if the customers are willing to wait, then going for shortages is preferable. So, some people think that the model with back orders will have a greater cost, because it includes a back order cost in addition to the usual inventory holding and ordering cost. You can point out the fallacy in this thinking by noting that the back order model leads to lower inventory, hence the lower inventory holding cost. I will explain this idea with the help of this expression. So, what is the justification for planned shortages? We have derived the optimal shortage quantity S star equal to Q star multiplied by CH upon CH plus CB. Here CH is the holding cost, CB is the back order cost. Whenever the CH increases, what is that? Whenever the holding cost is increases, the ratio become larger and the number of planned back order increases. So, a costly items, the value of the items are very high, for example, car and other items. If the holding cost is high, it is better to go for more shortages. That is this expression says, because the CH is in the numerator. When CH increases, when the holding cost increases, we should go for more shortages. This relationship explains why items that have high per unit cost and a correspondingly high annual holding cost are more economically handled on the backorder basis. On the other hand, when the backorder cost CB increases, the ratio becomes smaller and the number of planned backorder decreases. Thus, the model provides an intuitive result that the item with high backorder cost will be handled with few backorders. In fact, high backorder cost, the backorder model and the EOQ model with no backordering allowed provide similar inventory policies. Okay. So, what I mean to say, whenever there is a high backorder cost, whether you solve by planned shortages model or our traditional EOQ model, you will get the similar result. In this lecture, we have seen inventory model with the planned shortages. What are the concepts I have covered? I have derived an expression for the total cost. From the total cost expression, we have got the value for optimal order quantity and the optimal shortage quantity. Then we have taken a sample problem, then I have, with the help of sample problem, I have explained these concepts. Thank you very much. We will see you in the next class.